Hi everyone, welcome to another maths video by Maths with Sarah. So today we're going to be tackling this sort of trigonometry with a twist question. The twist being there aren't actually any triangles in it, but it definitely involves some trigonometry. So what we're actually looking at more is exact trig values. So this question would be pretty easy if it came on a calculator paper. You could just shove it all into your calculator and bingo, you'd have the answer straight away. Unfortunately, this question is a little bit more of a challenge because it comes from a non-calculator paper, so it's a paper 1, which means you've got to remember your exact trig values, or at least remember how to work them out. So that's what I'm going to be going through in this video is looking at exact trig values and how you can calculate those without needing to memorize them all, which for me is not going to happen. So as with all of these questions, I encourage you to pause the video, have a go yourself, and then come back to it and I will talk you through the whole thing. Okay, so let's take a look at this question. We've got show that the value of cos 30 degrees times tan 60 degrees plus sine of 30 degrees is an integer, i.e. a whole number. So let's have a think about how we can figure this one out. So anyone who knows me knows that I have a fairly terrible memory for just memorizing the exact trig values. If you can, absolutely great. Go ahead and do it that way. But for me, that's a real struggle. So what I'm going to do is just show you a quick method that I like to use for calculating the exact trig values rather than having to remember them. So all I have to remember here is just one triangle. I'm going to cut it in half. I'm going to be honest, this is not quite as to scale as it could be, but it'll work nonetheless. So we've got a triangle here. All the side lengths are the same size. In theory, they're all 2 centimeters, doesn't really matter too much. And because all the side lengths are the same size, we know that all of the angles are going to be the same size. So these are all going to be 60 degrees, with an equilateral triangle. Now I've cut the triangle in half down the middle. So that's completely bisected this angle. This one is now 30 degrees because we've only got half the angle. And this is bisected at there's 90 degrees. So we've got a right angled triangle. And because we've cut this side length in half, we're only going to be using this half of the triangle. So this side length will be 1 just up to this point here. So now we can use Pythagoras to calculate the value of this side here. And if we do that, we end up with 2 squared, which is 4, subtract 1 squared, which is 1. So then we get 3, and we need to square root it because Pythagoras. Let me just write that out for you. So we have got 2 squared, subtract 1 squared, because this is the hypotenuse, so we're going to subtract this side, and then we need to square root the whole thing. So if we do that, we end up with the square root of 4 take away 1, which is the same as root 3. And hopefully you're all confident. If you're tackling this question, I'm going to assume that you're confident with using this, leaving this as a surd or an exact number. Okay, so now we can start to solve this question. So if we're looking at cos 30, I'm going to do this cos 30 bit in red, just so that everything is easy to see where I'm going with it, because there's going to be lots of scribbles on this diagram. So we've got cos of 30 degrees. So we've got 30 degrees here. So if we label the side length, this is always going to be the hypotenuse. Then we've got the opposite the angle, and adjacent, which is the one next to the angle. So if we're looking at cos of 30 degrees, that's the same as the adjacent over the hypotenuse. So that will be the same as root 3 divided by 2. Okay, so we've got one number. Now let's have a look at tan of 60. So tan of, and then we'll put it all together at the end. So I just think it's easier. Let's solve all the separate bits to start with, see how that might end up being simpler than just putting it all together. So tan of 60. So now we still have the hypotenuse as it was before, but we're looking at 60 degrees rather than 30 degrees. So this one over here is now becomes the opposite because it's opposite 60 degrees. And this one is the adjacent because it's next to or adjacent to the 60-degree angle. So if we're looking at tan of 60 degrees now, we do tan, which is SOHCAHTOA, opposite, so root 3, over the adjacent, which is 1. Okay, now let's have a look at sine 30. So we've got sine 30 here. sine 30 degrees. So again, we're going to have to relabel all the sides. So again, we've always got this one as a hypotenuse, that doesn't change. Sine of 30, so we've got opposite, which is this one over here, and the adjacent, so it's the same as it is for cos, but it's always worth thinking about how you're going to label the sides. So sine is the opposite, so this side here, divided by the hypotenuse, which is 2. So we've got half. So now we can go back to the question and put everything all together. So we've got cos of 30, which we know is root 3 over 2, times by tan of 60, which we know is root 3 over 1. So I didn't really need to put the 1, but I'm going to do it just to make it easier so we can multiply by fractions. And then we're going to be adding sine of 30, which is 1 over 2. So let's try and untangle some of this. So now we've got root 3. So if we multiply by fractions, then we multiply the 2 on the top by the 2 on the bottom. So we've got root 3 times by root 3. So that just gives us 3. And then on the bottom, we've got 2 times by 1, which gives us 2. So that's the answer to this multiplying brackets. Then we're going to add a half. And so now what we've got is 3 over 2 plus 1 over 2, which should be reasonably easy to work out, is 4 over 2, which is the same as 2. So we have got the integer. So we've been asked to prove that this is an integer, i.e. a whole number. And look, we've proved that this is equal to 2, which is of course a whole number. If you're struggling with this, I have a couple of handy cheat sheets. So if you check out my Etsy page, I've got a really good trigonometry cheat sheet that you can buy for a small amount. I've also got an exact trig value one as well, which is on my Twitter and my Instagram. So I'd encourage you to check those out. They're really good for finding different ways of calculating exact trig values where you've only got one little bit to remember, rather than having to remember absolutely all of the numbers, which, yeah, as I said, is really difficult to do. So yeah, I'd encourage you to check those out. I've also got a few more other questions that involve exact trig values, which I'll tag in this video. So if you're struggling with this sort of question, then I encourage you to check those out. Lastly, please subscribe to the channel because it really makes it good for you to see all the new videos, maths videos coming out. And lastly, thank you very much for watching.